Hi everybody, today we're looking at L Hopitals Rule, and it says that if it's involved with limits, and if we're looking at the limit as x goes to a of f of x divided by g of x, where that result is going to be 0 over 0, so remember 0 over 0 is indeterminate, then if we take the derivative of f and the derivative of g, then and that limit exists, then the limit of f of x on g of x also exists and is the same as the limit as x goes to a of f of dash on g dash. Now note that we're not differentiating the division function. It's the derivative of f on its own on the derivative of g. So it's not the derivative of the whole function, it's the derivative of each of them. And we can use that so if we substitute a into f and g and we get 0 on 0, or we get positive or negative infinity on positive or negative infinity, those are the cases we can use it. So we can't use it in just any case, we've got to use it in these special cases. So we're asked to use the Hopitals rule to find these two given here. So if I first of all just substitute 1 in, well, ln of 1 squared on 1 take 1 gives me 0 on 0. So this is suitable to use for the Hopitals rule. Okay, so I'm going to do the derivative of ln x squared, so it will be the limit as x goes to 1 of ln of x squared over x take 1. Now, if that's the case, I've got to find the derivative of ln of x squared. So that will be 1 on x squared multiplied by the derivative of x squared, which is 2x, all over the derivative of x take 1, which is just 1. And so then I cancel the x's there, and I get 2 on x all over 1. Now I should keep my limit out the front. And so then I'm not going to get 0 on 0 anymore. Substituting in 1, I get 2 on 1 all over 1, which is just going to be 2. And so the limit is 2. In the second one, I've got the limit as x goes to 0 of tan squared on 1 take cos squared. So if I put in 0 here, I've got tan of squared of 0 and 1 take cos of 0. Tan of 0 is 0 and cos of 0 is 1, so it's 0 on 0. So this is another suitable form for L Hopitals rule. Okay, alright, so the limit as x goes to 0 of tan of x squared, I'm going to write it like this because it's helpful to make it easier to differentiate, over 1 take cos x, so it's the limit as x goes to 0. Okay, so the derivative of tan squared, so I bring down the 2, the tan of x stays the same, and I multiply by the derivative of tan of x, which is sec squared of x. And that will all be over the derivative of 1 take cos x. 1 goes to 0, and so minus cos x differentiates to sin x. Okay, so then I've got the limit as x goes to 0 of 2 of tan of 0 times by sec squared of 0 all over sine of 0. Now when I substitute in, I shouldn't have the limit, but if I look at that, we can see fairly quickly that that also doesn't work. That's also, so tan of 0 is 0, so that'll be 0, and sine of 0 is also 0. So it's also 0 on 0. And so then what we need to do is we just keep going. We differentiate again. So it's the limit as x goes to 0. Now, the derivative of 2 tan of x Now sec squared is 1 on cos squared. So I'm going to have to differentiate, and it's getting a bit more ugly, and then it's all over sine of x. Okay, so it's the limit as x goes to 0 of 2 of tan of x all over cos squared of x, and that's going to be all over sine of x. Okay, so let's differentiate. So I've got to keep my functions separate. I can't bring them together because I'm just differentiating sine of x and then differentiating all of this 2 tan x cos squared x. So it's the limit as x goes to 0. Now, whatever the derivative of the top line is, and we'll do that in a minute, it'll be over the derivative of sine x. The derivative of sine x is cos x, and cos of 0 is 1. So we're not going to get 0 on 0 anymore. So this is now going to resolve it. So the derivative of that top line, what's the derivative of the top? So it's the derivative of 2 tan x, which is 2 sec squared x, times by the bottom, so times by cos squared of x, minus the top function, 2 tan of x, times by the derivative of cos squared, which will be 2 cos x times by the derivative of cos x, which is minus sine x. Okay, and so then it's a matter of working it all out. Well, first of all, we can simplify a bit. So sec squared is 1 on cos squared. So we're doing 1 on cos squared times by cos squared. And then it's 2 tan x times by minus 2 cos x sin x. And that is all over cos x. And then we substitute 0 and we remove the limit. So the first term is 2. So it'll be 2 take 2 tan 0 times by minus 2 cos 0 times by sine 0. And we know tan 0 is 0, so it doesn't matter what anything else is. As soon as one of those terms multiplied together is 0, the whole term is going to be 0. And that's all going to be over cos of 0. So we'll get 2 take 0 over 1, and so then the answer there will be 2. Okay, so if L Hopitals Rule doesn't work in the first time, then you just differentiate again and go a second time. And hopefully you end up getting to a point where you can find a limit. Okay, and remember that when you substitute the value, you remove the limit. So going from this step to this step, substitute the limit and remove the limit. It's very important notation. Alright, okay. Now this last example says find the horizontal asymptotes of the function. Well, horizontal asymptotes occur as x goes to plus or minus infinity. So let's just focus on x going to positive infinity first. Of x squared take 1 all over x squared plus 1. And if I put infinity in to this, I'm going to get infinity on infinity. So x squared take 1 is going to be close to infinity. X squared plus 1 is just going to get larger and larger and go to infinity. So the limit as x goes to infinity, well, I need to differentiate the top line. So that will be 2x, and I need to differentiate the bottom line, which will also be 2x. So this is just the limit as x goes to infinity of 1. And because that's independent of x, the limit is going to be 1. So as x goes to positive infinity, the function is going to go to 1. Let's just check for negative infinity. Well, we can see it's going to be very similar because we're still just doing the derivative. And we're going to get the limit as x goes to infinity of 2x on 2x. So that's the limit as x goes to infinity of 1. So that's also the answer of 1. So therefore we have a horizontal asymptote of y equals 1. Okay, and that's the video done for today.